to our perfect classes. In this video, I will discuss first order differential equation of higher orders next topic, and this is last video of this topic. In this video, I will start from standard 2. Standard 1 I have discussed already in previous video. You can see there. Standard 2. The partial differential equations of the form that is f of x comma p comma q that is equal to 0. Second, f of y comma p comma q is equal to 0. Third, f of z comma p comma q is equal to 0. Case 1. The equation of the form that should be f of x comma p comma q that should be equal to 0. And here we will set q is equal to a in the given partial differential equation. After that, solve the resulting equation for p in the terms of x and a, like let p is equal to g of x a, x comma a, and then we have to find dz p d equal to p dx plus q dy, and equal to g of p is equal to g of x comma a. Then we will be substitute here p's value g of x comma a dx plus and q's value that should be equal to a, and so that's why we will write here q instead of q we will write a dy, and in place of p we will write g x comma a, and after that integrating this equation, and we will get the complete integral like z is equal to integration g x comma a dx plus ay plus c, where a comma c are arbitrary constant. Now I am taking one example. We have given statement square root p plus square root q is equal to x. The partial differential equation of standard 2. So first of all, setting q is equal to a square, because we have given square roots, and for solving the square root we will take here a square in the given equation, and we will get p square root p plus a that is equal to x, and after that p is equal to x minus a whole square. Now from dz, equation is p dx plus q dy. Instead of p we will write x minus a whole square, and instead of q we will write a square, and after that integrating of this equation we get complete integral as like z equal to integration of x minus a whole square dx plus integration of a square dy, and we will find z equal to x minus a whole cube over 3 plus a square y plus c, where a and c are arbitrary constant, and in general integral form we will write z is equal to x minus a whole cube over 3 plus a square y. Instead of c we will write g of a in general integral form, and in singular integral it is an absurd result, so it is not singular integral. Now next type is standard 3. The partial equation form is of form f1 x comma p that is equal to f2 y comma q. In partial equation of the form f1 x comma p that should be equal to f2 y comma q. Now first function f1 of x comma p equal to f2 y comma q that should be equal to a. First of all it should be taken as a. Then we get p is equal to phi 1 x comma a bracket then dx, and after that plus phi 2 y comma a dy, and then integrating, and we get z is equal to integration of phi 1 x comma a dx plus integration of phi 2 y comma a dy plus c, and it is a complete integral. When we change c, we write g of a instead of c, that is general integral form, and eliminating a and a between z and derivative of z with respect to a equal to 0, we get general integral. And in singular integral, differentiating z partially with respect to c and equating to 0, we get an absurd result, so it is no singular integral. Here I am taking one question, one example. Solve p plus q is equal to x plus y is a statement given. First of all, you have to write the partial differential equation is of the form f1 x comma p, that is equal to f2 y comma q. After that, we have to put p minus x, means this equation written like this: p minus x equal to y minus q. X written here and q written this side by changing sign, and p minus x is equal to y minus q, that should be equal to taken a, and so p is equal to x plus a. P minus x is equal to a, and p is equal to x plus a, and q y minus q is equal to a, then y is equal to a plus y plus sorry, q is equal to y minus a. Now after that, write p dx plus q dy is equal to dz. This step you have to take this step, and after that dz is equal to write p's value x plus a and q's value y minus a, and integrating this equation, and after integrating of this equation we will find out x plus a is whole square over 2 plus y minus a is whole square over 2 plus c. When we interchange c's value by g of a, then it will be converted into general integral form like this. And after that, singular integral, it is not a singular integral because it is equating to 0 and it is an absurd result, so that's why it is not a singular integral. Standard 4, this is the form of z is equal to, when we have given statement in this format, that then we will implement standard 4, px plus qy plus f of p comma q. For example, we will solve this equation like this: z is equal to ax plus by. We will take p's place value a and q's place value b, and after that plus function of p comma q. P is equal to a and q is equal to b. Now take a one question: z is equal to px plus py plus root square root 1 plus p square plus q square. We can say that it is this question is px plus py qy, and plus this is a equation of function of p comma q. Now we will put it z is equal to, we write p's value a, and this p's value we will write b, and after that 1 plus a square plus b square. It's minor mistake, it will be here, right? We will write here q, this is q. Now after that we will write this is a complete integral, and when we write instead of b is a function of a, then it should be general integral z equal to ax plus f of a y plus in square root 1 plus a square f a whole square, and after that where f is an arbitrary, differentiating partially with respect to a and eliminating a between the two equations, we get the general equation integrals. In singular integrals, differentiating partial with respect to a and b, x plus a over square root 1 plus a square plus b square equal to 0, and y plus b over square root 1 plus a square plus b square, that is equal to 0. And after that, eliminating a and b singular integrals, we will find out x square plus y square plus z square, that is equal to 1. This equation is for singular integrals. Now after that, we will discuss next very important topic, that is Lagrange's linear equation. A linear partial differential equation of first order known as Lagrange's linear equations. In this equation will be given in this form: P of p plus capital Q small q is equal to r. Capital P, capital Q, capital R are the function of x, y and z. And rules will be implemented. First of all, you have to check the equation will be given in this format or not. Then implement form the auxiliary simultaneously equation: dx over p plus dy over q is equal to dz over r. And after that, third step, we implement solve the step 2 by using a u is equal to a and v is equal to b. And then step 4, phi u comma v, that should be equal to 0, or you can say u is equal to function of v, or you can say v is equal to capital F of u. After that, we will take here one question: find the general integral of px plus qy is equal to z. Comparing the equation with the pp plus qq is equal to r. Here we will take capital P is equal to small x, capital Q is equal to y, small y, and capital R is equal to small z. And the subsidiary equations are dx over x plus is equal to dy over y is equal to dz over z. Now in this variables are separated, so dx over x is equal to dy over y, and taking the differentiation both side, by taking differentiation we will get log x is equal to log y plus log c1. And then we will take log x equal to log y c1 and log cut with the log, and we will find x over y is equal to c1, that is first equation. And similarly, dy over y is equal to dz over z, and by cross multiply y taking the differentiation, log y is equal to log z plus log c2. And after that, implementing formula of log m plus log n, that should be equal to log mn. So that's why here we will write log to log zc2, log cut with log, and y z over z is equal to c2, second equation. Hence solution will be phi x over y comma y over z bracket close equal to 0. This is the general solution. Now next is a linear differential equation with the constant coefficients. Method is a linear differential equation with constant coefficients. For this, first of all, you have to consider a linear equation of second order with the constant coefficients. That should be will be given in the form this form: a d square y over dx square plus b dy over dx plus cy is equal to x. This is first equation. When we have given in this form equation, that is the second order with the constant coefficient linear equation. After that, we will write where a comma b c are constants, and a capital X is a function of x. Now consider equation: a d square y over dx square plus b dy over dx plus cy is equal to 0. That is the second equation. The solution of this equation is the solution of this equation 2 is called the complementary function of 1. The equation am square plus bm plus c is equal to 0, that is called the auxiliary equation of the equation 1. And 3 cases can arise in the solution of auxiliary equation. First case can be arise let the auxiliary equation 3 has two real and distinct roots m1 and m2. Then we can say it will be y is equal to a e raised to power m1 x plus b e raised to power m2 x is a general form of equation 2. And according to case 2, let auxiliary equation 3 has two roots equal and real, and let in this case let m1 equal to m2 and equal to m say, then we can say y is equal to ax plus b whole multiply e raised to power mx in the general form of equation, solution of 2. If case 3, then let the auxiliary equation 3 has imaginary roots, as imaginary roots occur in the pairs, then we can say let m1 is equal to alpha plus iota b beta, where alpha and beta are the real, then m2 is alpha minus I beta. Now then we will take this general solution. Y is equal to e raised to power ax a cos b beta x plus b sin beta x, and it is a general solution of case 2. Case 3, after that we will discuss one questions regarding this type. We have given equation d square y over dx square minus 5dy over dx plus 4y is equal to 0, and its order is 2 and a degree also 2, so that's why highest degree is 2 and order is 2. We will write it first of all m square minus 5m. We will take this value is m square, and this value will be written as a m and plus 4. Then we will solve this equation by factorization method, and we will find out 2m1 m1 and 4 both are the roots real and distinct. So thus we can say we can implement here first equation a first according to case 1 a e raised to power x plus b e raised to power 4x is a general equation. How you can see here in case 1 a e raised to power m1x plus b e raised to power m2x, and we put here only values in equation. m1 is 1 and m2 is 4. Here equation is a e raised to power m1x plus b e raised to power m2x, and we will put here value 1x plus b e raised to power 4x. So that's why we will write this equation. And now to find the particular integrals, consider the equation 1 which can be written symbolically as a d square plus b d plus c y is equal to x. We can write it in this form first, and after that you can say function of dy is equal to x, where f d is a d square plus b d plus c, and let y is equal to u, a particular solution of this equation. So let y be the complementary function of 1. Then we can say y is equal to, this is gamma plus u is the general solution of 1, and u is the called particular integral of function of 1 equation, and in symbolic form it is written as 1 over f dx. And after that pi we have to find out 1 over f d x is equal to 1 over f d is a d square plus b d plus c, and here we will write x. And we have to implement four types of four types. So first type 1 is we should be take here let x be the of form e raised to power alpha x. Pi is equal to 1 over f dx. We can write instead of x e raised to power alpha x. And in type 1 there are different cases. Case 1, in according to case 1, if f of alpha is not equal to 0, then we can say 1 over f of d e raised to power alpha x, that should be equal to 1 over instead of d we will write here alpha, so we will write here also e raised to power alpha x. Hence rule is replace d by alpha if alpha beta function of alpha is not equal to 0. In according to case 2, if alpha function of alpha is equal to 0, then alpha statistics satisfies the equation of f of m is equal to 0. Then we proceed as follow. First, we will let the auxiliary equation have two distinct roots m1 and m2, and then we will assume let alpha is equal to m1, then pi is equal to x over a alpha minus m2 e raised to power alpha x. According to second point, and let auxiliary equation have two equal roots, then each equal to alpha, that is m2 is equal to m1 and equal to alpha. So we will write pi is equal to x raised to power 2 over 2 e raised to power alpha x. Now we have given a equation d raised to power 2 plus 5d plus 6 y is equal to e raised to power x. We have to prove the auxiliary equation m square plus 5m plus 6. We will, when we solve this equation by factorization method, we will find out m is equal to minus 3 and m is equal to minus 2, and both are the real roots and distinct roots, and these the complementary function of this is e raised to power minus 2x plus b raised to power e minus 3x, and pi is equal to 1 over function of d square plus 5d plus 6 e raised to power x, and here we will replace the d square by the 1, and so that's why we will write here 1. Now d replaced by 1, 5 into 1, 5, and we will find 1 by 12 e raised to power x is the pi, and after that we will implement all these values in cf plus fpi, and we will find general solution. Now next is type 2. Let x be the form of sine alpha x or cos alpha x, where alpha is a constant. Pi is equal to 1 over 5 d square sine alpha x is equal to 1 over 5 alpha minus alpha square sine alpha x. And after that, first point rule is replace d square by minus alpha square if 5 minus alpha square, that is not equal to 0. And after the second point, second rule is implement if 5 minus alpha square that is equal to 0, then d square plus alpha square is a factor, and here we can say hence 1 over d square plus alpha square sine alpha x is equal to minus x cos x cos alpha x over 2 alpha x alpha, and we can say 1 over d square plus alpha square cos alpha x is equal to x sine alpha x over 2 alpha x 2 alpha, and now I am taking one example for solving this type 2. D square minus 3d plus 2 in bracket y is equal to sine 3x. We have to prove it. Thus auxiliary equation is m square minus 3m plus 2, and after solving this equation we will find m is equal to 2 and m is equal to 2 and another m is 1 by taking factorization method. M square minus 2m minus m plus 2 equal to 0. M comma, we will take here m common, here we will take m common, and m minus here 2 and 1 common, m minus 2 in bracket equal to 0, m minus 1 and m minus 2 that is equal to 0, m minus 1 equal to 0, m minus 2 equal to 0, and we will find m equal to 1 and m equal to 2. That means one value of m is 2 and another value is 1. Here we put a is a e raised to power 2x plus b e raised to power x, and pi that should be equal to sine 3x over d square minus 3d plus 2, and sine 3x over minus 9 minus 3d plus 2, and here d square replaced by minus alpha square, and minus alpha square replaced by minus 9, minus 9 3d plus 2, and after when we solve it, that is minus 7 minus 3d, and we take a rationalization method, and after that we multiply numerator with the numerator and denominator with the denominator. We will find 7 sin 3x minus 3d sin 3x over 7 7 is the 49 minus 49 minus minus plus 3 3 is the 9 d square, and minus 7 3x minus 3d sin 3x over minus 49 plus 9, and d square and d square replaced by minus 9, and we will find here minus 130 after solving all whole denominator, and numerator will be minus sine minus 7 sine 3x minus, and sine 3x is equal to 3 cos 3x, it is a formula, so that's why we will write here, and after multiply we will find out minus 9 cos 3x, and after that CF will be complementary factors will be 7 sin 3x minus 9 cos 3x over minus 130, and pi is equal to minus 7 sin 3x minus 9 cos 3x over 130, and after adding both, we will find out general equation that should be equal to a e raised to power 2x plus b e raised to power x minus, and this value will be pi, and according to type 3, let x be of the form x raised to power m, m being a positive integer. You should be keep in mind m will be positive integer, and now next to evaluate, first of all you have to evaluate 1 over fd x raised to power m, and raise f2 fd to power minus 1, and expand in ascending power of d as for as a d raised to power m. You have to write d raised to power m, and these terms in the expansion of function of d power minus 1 and operating on x raised to power m give the particular integral required. We take here one example. We have to solve this equation. Solve d raised to power y over dx square plus 2 dy over dx plus 3y is equal to 5x square. Now first we have to find out CF. For finding CF, we will be solved d square plus 2d plus 3y is equal to 0. You can see here equation is, we will write here d square plus 2d plus 3 equal to 0, but we will write with this like y, and it should be equal to 0 first, and after that taking auxiliary equation m square plus 2m plus 3 that is equal to 0, a is equal to 1, b is equal to 2, and c is equal to 3, and m is equal to minus b plus minus square root b square minus 4ac over 2a. When we substitute whole values, we will find this. When we find minus in square root, then it will be right like into 8. Minus 1 in square root, that should be equal to iota, and its 8's square root will be 2 square root 2. So that's why we will write here 2 iota. This is a iota, not a I, it is a iota. And after solving this, we will find out alpha is equal to minus 1 and b is equal to root 2. And CF is equal to e raised to power minus x, a cos root 2x plus b sin 2 root x, and pi is equal to 5x square over d square plus 2d plus 3 and is equal to 5x square, and d square replaced by 3 plus 2d plus d square, and 3 take as a common 1 plus 2d plus d square over 3, and after that 5 by 3. We will take here 5 by 3 outside of this square bracket, 1 plus 2d plus d square over 3 the whole power minus 1, and implement here binomial theorem. According to binomial theorem, 5 over 3 1 minus 2d plus d square over 3 its power 1, and after that we will take here power 2, 2d plus d square over 3 whole power 2, and 5 by 3 1 minus and this x square will be written here, and then 2d plus d square over 3 a square plus b square's formula implementing here, and that will be 4d square plus 4dq plus dq4 and over 9 and x square written as it. After that 5 by 3 1 minus 2d plus d square over 3 plus when we solved 2d plus d square whole power, it will be solved like this, plus d square of square plus 2d into d square over 3, 4d square plus d power 4 plus 2 to the 2d power 3 over 3 square means 9, like this, and here d power 4 plus 2d raised to power 3, d raised to power 4 to d raised to neglecting highest power. These powers should be neglecting, so that's why we will remaining value 4d square over 9 x square, 5 over 3 x square minus 2d this x square multiply whole equation, then we will find this equation. After that x square minus 2 and this d, that should d here we will write 2x into 2x into dx, and you can say that here dx square change into 2x. In place of dx square we will write 2x, and d square x square place we will be write 2 over 3. For d square x square's place we will write here 2. Replace these values, and after solving a whole equation we will find 5 by 3 x square minus 4x plus 2 over 3 plus 8 by 9, 5 by 3 x square minus 4x plus 3, and write these equation separately, minus 4x over 3 plus minus minus 2 by 3 plus 8 by 9. Now take now solve these two equations. Taking LCM is 9 minus 6, 3 3 to the 6 plus 8, it will be finding a 2 by 9, and after that y is equal to CF plus PI. You will write e raised to power minus x a cos root 2x plus b sin root 2x, and PI will be plus 5 by 3 x square minus 4x over 3 plus 2 by 9. Now next is a type 4. Let x be of the form e raised to power ax, f capital Fx, where capital F of x is any function of x. Pi is 1 over fd e raised to power ax function of x, that should be equal to e raised to power ax over f over d plus a function of x. Rule is replace d by d plus a. And now I am going to solve equation d square plus 4y is equal to e raised to power 2x sine 2x. The auxiliary equation, that should be m square plus 4 equal to 0. When we solve it we will find out m will be 1 plus minus iota 2. You can say m is equal to plus minus 2 iota. Now the roots are imaginary. CF is equal to e raised to power 0x, a cos 2x plus b sin 2x, a cos 2x plus b sin 2x. It will be equal to 1, and pi is equal to e raised to power 2x sin 2x over d square plus 4. It is here pi, and after that putting in the general solution CF plus PI. How to find this? How to find? Just a minute. We will find here PI is equal to e raised to power 2x, because we will according to type 4, PI is equal to 1 over FD, and e raised to power ax fx. So that's why we will write here P is equal to e raised to power 2x sine 2x and over 1 over f d square plus 4, and after that we will solve it. E raised to power 2x sine 2x and d replaced by d plus 2. D instead of d we will write d plus 2 whole square, and when we solved it, that will be d square plus 4d plus 8. It is answer a square 2x sine 2x, and here d square replaced by minus 4, and when we solved e square 2x 4d minus 4 over 4d plus 4 and 4d minus 4 and sine 2x, and this will be, just a minute, here we will find you can see 8 minus 4, that should be equal to 4 plus 4d, and here e raised to power 2x sine 2x, and when we multiply when we rationalize 4 minus 4d, then we will find out 4 e raised to power 2x sine 2x minus 4d e raised to power 2x sine 2x over 4 4 is the 16 minus 4 4 16 d square, and d square is replaced by minus 4. That's why we will write here this format. You will find this, and after that you should be implement e square 2x 4d sine 2x minus 4 sine 2x over 16 into 4 minus 64, and we will find out denominator minus 80, and here we will take common 4, and 4 e square 2x 2 sine 2x value, that should be equal to 2 cos 2x, and sine 2x as it here, and after that 4 e 2x 2 cos 2x minus sine 2x, and after that general format you should be written as it. Thus we in this video I have complete all methods of first order differential equation from standard tools to till end, and after that we can say that you have to prepare